Swayam Prabha. Digital India. Educated India.
Now, in the continuation of problem activities, we are going to discuss the Bernoulli trials related problem from a lot containing 25 items, 5 of which are defective, 4 items are chosen at random and x is the number of defective found. The question is to obtain the probability distribution of x when the items are chosen and subdivision without a replacement with a replacement. So, 2 cases we have to discuss. So, here we are having 4 items and then x can take the values of 0, 1, 2, 3 and 4. So, lot containing 20 non-defective and 5 defective items. So, we have 2 cases, one is replacement and without replacement. Let us start with without replacement. When the items are chosen as without replacement, we can assume that all 4 items are chosen simultaneously. So, probability of x equal to r mean probability of x equal to exactly r defective items. So, choosing r defective is 4 minus r good items. So, the meaning is n equal to 5. So, 5 CR into 20 C 5 minus R 4 minus R and then 25 C4. So, choose the values of R equal to 0, 1, 2, 3 and so on 4 and we have without replacement. So, with the replacement the item are chosen with the replacement. So, the probability of item being defective remains the same in each draw. Therefore, probability of 5 by 25 equal to 1 by 5 because totally 20 non-defective, 5 defectives, total outcome is 25 and we are going to choose the 5, therefore 5 by 25 and cancel we have 1 by 5 and once you got the P and Q equal to 1 minus P, so that 1 minus 1 by 5 equal to 4 by 5 and we have for n equal to 4. So, the problem is one performing 4 Bernoulli trials and finding the probability of 4 CO r into 1 by 5 whole power r into 4 by 5 into power 4 minus r equal to 0 choose corresponding probability of x equal to 0 and probability of x equal to 1 4 C1 1 by 4 into 4 by 5 4 minus 1 is 3 when r equal to 2 4 C2 equal to 1 by 5 whole power 2 into 4 by 5 4 minus 2 and 3 probability of x equal to 3 is 4 C3 into 1 by 5 whole cube into 4 by 5 whole power 4 minus 3 when r equal to 4 C 4 into 1 by 5 whole power 4 into 4 by 5 4 minus 4. So, these are all the possibilities will come. So, that is the answer to the first question. Now, let us go into discuss the second question. A shipment of 6 television sets contains 2 defective sets. A hotel makes a random purchase of 3 of the sets and then x is the number of defective and purchased in the hotel, find the probability distribution of x. So, all the 3 sets are purchased simultaneously. Here all the 3 sets are purchased simultaneously since there are only 2 defective sets in the lot. So, x can take the values 0, 1 and 2. So, probability of x equal to r equal to probability of choosing exactly r defective sets and r defective sets rather we can write choosing r defective and 3 minus r good sets. So, for television set 6 television set and 2 defective sets therefore 2 CR. Out of 2 defective and 4 is out of 6 2 defective and rest of them 4 are not defective therefore 4 C 3 minus R divided by total number of outcome is 6 and we are going to choose the random purchase of 3, therefore 6C3 is the total number of outcomes. So, this is the answer for probability of choosing exactly or defective. Now, R may be 0, 1, 2. Now, the required probability distribution is represented in the form of the following table, and substitute R equal to 0. Therefore, 2CR into 4 into C suffix 3 minus R, R is 0. So, 4C3 divided by 6C3. So, 2C naught is 1, 1 into 4C3 by 6C3, and this is the answer for 1 by 5. So, 4C3 is nothing but 4 by 3, 6C3 by nothing but what? 6 minus 3 is 6C3 once again, 6 into 5 into 4 divided by 1 into 2 into 3. After simplification, we have 1 by 5 will come. Similarly, probability of x equal to 1, you take it, and then say probability of x equal to 1, we have what? 2C1 into 4C3 minus 1 by 6C3 is equal to 2 into 4C2 divided by 6C3, and 2 into 4 into 3 by 1 into 2 by 6 into 5 into 4 by 1 into 2 into 3. Therefore, 2 into 3 is 6 get cancelled, and 4 get cancelled, and then 6 by 10, that is 3 by 5. So, this is a way we can write probability of x equal to 1, and the similar way probability of x equal to 2 is 1 by 5 will come. Sum them, we have 1 plus 3 plus 1 divided by 5 is 1 will come. So, total probability 1 is coming. Next example, a random variable x may be assumed 4 values with the probabilities 1 plus 3x by 4 into 1 minus x by 4, 1 plus 2x by 4, 1 minus 4x by 4. Find the condition on x so that these values represent the probability function of x. Now, what you have to do? Probability of x equal to x1 is nothing but p1, which is equal to 1 plus 3x by 4, and p2 is 1 minus x by 4, and p3 is 1 plus 2x by 4, and p4 is 1 minus 4x by 4. So, the given probability represent the probability function. Each pi is positive and a summation of pi equal to 1. So, in this problem, the sum p1 plus p2 plus p3 plus p4 equal to 1 for any x, and p1 is positive if x is greater than or equal to minus 1 by 3, if p2 is positive if x is less than or equal to 1, if p3 is positive, x is greater than or equal to 1 minus 1 by 2, and p4 is positive, then x is less than or equal to 1 by 4. So, this is easily deducted with the help of the p1. Say for example, you take p1 equal to 1 plus 3x by 4, right, and you think about that p1 is positive. What happened? 1 plus 3x by 4 is positive, and then 1 plus 3x is greater than or equal to 0. So, 3x is greater than or equal to minus 1, therefore, x is greater than or equal to minus 1 by 3. So, this is the way we can deducted x is greater than or equal to minus 1 by 3. Similarly, go with the p2, p3, p4. Therefore, the value of x for which the probability function is defined lie in the interval of, you check it out here, right. See, minimum value of x is minus 1 by 3, maximum value is 1 by 4, and together we have minus 1 by 3 less than or equal to x less than or equal to 1 by 4. So, this is the range we can found out, that is the condition of x, and the values represent the probability function of x. Next example, the random variable x takes the values 1, 2, 3 and 4 such that 2 into p of x equal to 1 and 3 into p of x equal to 2, which is equal to p of x equal to 3 and equal to p 5 into p of x equal to 4. Find the probability distribution and the cumulative distribution function of x. Now, here we have given that let p of x equal to 3 equal to 30k, assume it. Now, the condition is twice of probability of x equal to 1 and thrice of probability of x equal to 2 and probability of x equal to 3 equal to 5 into probability of x equal to 4 is given. Now, first step 2 into p of x equal to 1 is equal to 30k, because 2 into p of x equal to 1 equal to p of x equal to 3, therefore, p of x equal to 3 is a 30k we assumed, therefore, substitute it, therefore, 2 into p of x equal to 1 is 30k, can write. So, we know that 2 into p of x equal to 1, therefore, 2 and 30 is divide them, therefore, p of x equal to 1 equal to 15k come. Similarly, you go to p of x equal to 2, that is already we taken 10k because p of x equal to 2 and p of x equal to 3 are equal, therefore, p of 2 into that is already given 3 into p of x2 equal to 30k, right. 3 into p of x equal to 2 equal to what? 30k, because 30k is equal to p of x equal to 3 and this divide. So, 10 times of k, therefore, p of x equal to 2 equal to 10k. So, similarly, p of x equal to 4, that is 5 into p of x equal to 4 equal to what? P of x equal to 3 and p of x equal to 3 is 30k, therefore, 5 into p of x equal to 4 and 5 and 30, therefore, 6k will come. So, p of x equal to 4 equal to 6k, therefore, this value arrived. Once you found out p of x equal to 1, 2, 3 and 4 and all are equal, and as per the rule of distribution function, we have to add, since summation of pi equal to 1, therefore, what 15k, 10k plus 3k plus 6k is maximum value 1, and add them, we have k equal to 1 by 61. So, in this way we can find out probability distribution of x is given by the following table, where I equal to 1, 2, 3, 4 and corresponding probability is what? Pi equal to k equal to 1 by 61, substitute here, and k equal to 1 by 61 into 10 is 10 by 61 and k equal to 1 by 61, therefore, 30 by into k is 30/61 and another one is 6 by 61 arrived. So, this way we can find the table of the probability distribution. So, based on this, the cumulative distribution function capital F of x defined by f of x equal to p of capital X less than or equal to x. So, accordingly, the CDF for the above distribution is when x is less than 1, f of x equal to 0. When 1 less than or equal to x is less than 2, then f of x equal to p of x equal to 1 is 15 by 61. So, This already we taken the table of this one, and we have f of x equal to p of x equal to 1 is 15 by 61. If we have the interval 2 to 3, then f of x is p of x equal to 1 plus p of x equal to 2. That is the meaning of capital F of x corresponding the interval 2 to 3. So, already we know that p of x1 is 15 by 61 and p of x2 equal to 10 by 61, then add them 25 is 61. So, this is the value we can get it. Then the distribution function calculate from 3 to 4. So, f of x is probability of x equal to 1, x equal to 2, x equal to 3. Therefore, 15 by 61 plus 10 by 61. So, already we found that corresponding 3 is 30 by 61. So, 30 by 61 substitute here. So, take LCM 61 and the numerator is what? 25 plus 30 is 55. So, that is the value of when x lies between 3 to 4. Suppose x is greater than or equal to 4, then f of x equal to 1, x equal to 2, x equal to 3 and x equal to 4, and you know the value of x equal to 1. So, this is 15 by 61 and this is 10 by 61 and this is 30 by 61 and this is already we found out, that is 6 by 61, and then add them, we have 61, the numerator is 15 plus 10 plus 30 plus 6 which is equal to 61. Therefore, the maximum value is 1 derived. So, this is the meaning of cumulative density function we can calculate with the help of this problem. Next, a random variable x has the following probability. So, x takes the value -1, -2, -1, 0, 1, 2, 3, corresponding p of x is 0.1, k 0.2, 2k, 0.3 and 3k. Now, find k and evaluate p of x is less than 2 and p of -2 to 2 you have to calculate. Find the cumulative density function of x and evaluate the mean of x. Now, we have a solution. S of p of x means summation of p of x equal to 1. Therefore, here we have what totally how much, k plus 2k plus 3k is 6k, 0.1 plus 0.2 plus 0.3 is 0.6. Okay, simply add p of x. So, that 6k plus 0.6 is 1 and 6k equal to what, 1 minus 0.6. So, 1 minus 0.6 is 0.4. Therefore, k equal to 1 by 15 will derived. So, we got the value of k. Once you know the k value, therefore, the given probability distribution can be written as x is given here -2, -1, 0, 1, 2, 3 and p of x you take the value 0.1 mean 1 by 10, k value 1 by 15 directly substitute here and here 0.2 mean 1 by 5, 2 into 1 by 15 and 0.3 is 3 by 10, 3k is 3 into 1 by 15 is what, corresponding 1 by 5. So, this way we can design the corresponding value of k. Therefore, find value of k, determine and the entire probability of a description of the distribution is given. So, that is the answer to the first question subdivision. Now, we have to evaluate p of x is less than 2 of the second question and find the interval between -2 to 2. So, once you learn k equal to 1 by 15 and the probability distribution function, we can easily do the second question. So, P of x is less than 2 mean probability of x equal to -2, -1, 0 or 1, these are all less than 2. So, it means probability of x equal to -2, probability of x equal to -1 and probability of x equal to 0 and probability of x equal to 1. Here x equal to -2 and x equal to -1 are mutually exclusive. Therefore, the corresponding value is here 1 by 10, 1 by 15, 1 by 5, 2 by 15. So, simply add them, we can get it, because we found out the value of -2, -1, 0, 1, 2, 3 corresponding entry also found out. Simply substitute here so that you can get the value. Now, to be determined P of -2 to 2, and the rule is probability of x equal to -1, because x lies between extremities values excluded, because it is strictly less than, therefore, it lies between -1, 0 and or 1. Therefore, probability of x equal to -1, x equal to 0 and x equal to 1. So, corresponding value from the table, probability of x equal to -1 is 1 by 15 and probability of x equal to 0 is 1 by 5 and probability of x equal to 1 is 2 by 15, and take the LCM, we get 2 by 5. Now, we have a third questions, f of x equal to 0 when x is less than -2. So, the corresponding data we can substitute. Therefore, you know the table, right, -2 is -1 by 10 and this value you have to remember, and then we can substitute here the ranges of -2 to -1, -1 to 0, 0 to 1, 1 to 2, 2 to 3 and above less than 3. So, these corresponding value from the table associated with the function. Now, next subdivision. So, the mean x is defined as E of x equal to summation x of P of x. So, the mean of x is nothing but -2 into 1 by 10, -1 into 1 by 5 and 0 into 5. Okay, so, mean is nothing but what? Summation x into P of x. Now, we have summation expectation of x is nothing but x into P of x. So, the mean of x is nothing but x, take the value -2, -1, 0, 1, 2, 3. This is a table value that is given here. -2, -1, 0, 1, 2, 3 is x value. Therefore, the rule is x into P of x, corresponding P of x value also found out and substitute it, so that from the table you can get the value. So, we have -2 into 1 by 10 is -1 by 5 and -1 by 15, 2 by 15, 3 by 15, 3 by 15 equal to 16 by 15. Next example, the probability function of a infinite discrete distribution is given by P of x equal to j, which is equal to 1 by 2 power j, where j varies from 1 to infinity. So, we have to verify the total probability is 1 and find the mean and variance of the distribution. Also find P of x is even, P of x less than or equal to 5 and P of x is divisible by 3. So, these are all the 3 questions to be determined. Probability of x equal to j equal to P of j is nothing but the given question, probability of x equal to j is 1 by 2j, where j varies from 1 to infinity. Therefore, j equal to 1, 1 by 2, when j equal to 2, 1 by 2 square, when j equal to 3, 1 by 2 cube and so on. Now, you see this expression is a geometric series. Here first term a equal to 1 and also it is infinite series. So, the rule is a by 1 minus r. So, a is equal to half 1 minus 1 by 2, which is equal to half by half, which is equal to 1. So, that is the value of summation of this probability is 1, and if x is defined in E of x, summation j equal to 1 to infinity j into p of x, and also discussed in the chapter. So, expectation of x is equal to, simply you put j equal to 1, therefore 1 into p1, 2 into p2 and so on. Therefore, corresponding probability here is a square, a cube and so on. Therefore, a 2a square, 3a cube and so on infinity will come the series expectation of x. Here a equal to 1 by 2. Therefore, what happened? The series will come a into 1 plus 2a plus 3a square and so on. Now, this is the binomial expansion a into 1 minus a the whole power minus 2, and simplify a is half. So, half into 1 minus 1 by 2 whole power minus 2, 1 minus 1 by 2 is half, half power minus 2. So, half by half square is 1 by 1 by 2 is 2. So, this way we can calculate the expectation of an event, and similarly the variance of x is expectation of x square variance of x is e of x square minus e of x the whole square. So, e of x square is nothing but j equal to 1 to infinity j square into pj. If you take j equal to 1, then j equal to 1 to infinity j square into a power j, where a equal to half. Now, j varies from 1 to infinity. Therefore, what happened? It becomes j into j plus 1 minus j. You know j square. So, 1 square, see this expansion is 1 square into say j is 1 a, and then 2 square into a square plus 3 square into a cube and so on will come. So, we have the series expansion, right, n into n plus 1 of this minus j adjustment into a power j. So, it means j square plus j minus j. So, this is adjustment we have to do. Now, the series expansion we can do in terms of j into j plus 1 minus j into a power j. So, this reduces to j into j plus 1 into a power j minus j into a power j. Now, when j varies from 1 to infinity, then the series is nothing but a is a common, and then we can split j substitute 1. So, 1 into 2, 2 into 3a, 3 into 4a square and so on infinity. Next term a into 1 plus 2a plus 3a square and so on infinity. So, the term this one is a into 2 into 1 minus a the whole cube minus a into 1 minus a the whole power minus 2, this is expansion of binomial. Now, the problem reduces to, so this is 1 minus a whole power minus 3, therefore 2a by 1 minus a whole cube minus a by 1 minus a the whole square, and take LCM and simplify, that is what 2a minus a into 1 minus a by 1 minus a the whole cube, which is equal to 2a minus a plus a square by 1 minus a the whole cube. So, it becomes what? A square plus a by 1 minus a the whole cube, right, and substitute the value of a equal to half, right. So, what happened? A into, that is half square plus half by 1 minus half into whole cube, so which is equal to 6. So, the value is 1 by 2 the whole power 2 is 1 by 4 plus 1 by 2 by 1 by 2 the whole cube. the net value is 1 by 6. So, this is the meaning of expectation of x square. Now, variance of x is expectation of x square minus expectation of x the whole square. We already found out E of x. E of x is a 4, E of x square is a 6, subtract them we have a 2. Therefore, probability of x is even is probability of x equal to 2 or x equal to 4 or x equal to 6. Therefore, these are mutually exclusive. So, this is the series expansion of what 1 by 2 plus 1 by 2 the whole power 4 and so on. So, it is the geometric series of the first term is 1 by 2 the whole square or 1 by 2 the whole square, take it common. So, it becomes 1 by 2 plus 1 by 2 the whole square, 1 by 2 whole power 3 and so on. Therefore, for the geometric series of infinite series, A here is what 1 by 1 minus 1 by 2, right. So, what happened? It become 1 by 1 by 2 the whole square, right. So, we have 1 by 2 this 1 by 4 into 1 by 1 minus 1 by 4, which is equal to what? 1 by 4 by 1 minus is 3 by 4, 4 get cancelled, therefore 1 by 3, that is the first step answer. Similarly, probability of x is greater or equal to 5 is probability of x equal to 5 or x equal to 6 or x equal to 7 and so on up to infinity. So, probability of x equal to 5 plus probability of x equal to 6 and so on infinity. So, it seems to be a geometric series of 1 by 2 power 5 by 1 minus 1 by 2 equal to 1 by 16. Next one is probability of x is divisible by 3, in the sense that what are all the variable will come either 3 or 6 or 9 etc. So, probability of x equal to 3 is 1 by 2 the whole cube, 1 by 2 the whole power 6, 1 by 9 the whole power 3, 9 and so on up to infinity. Once again this problem comes in the geometric series. So, the first term is 1 by 8 and the difference is 1 by 8, therefore, A by 1 minus R. So, A is 1 by 8 and R is 1 by 8, therefore, 1 by 8 minus by 1 minus 1 by 8. So, take the LCM and we have 7 by 8 and we have 1 by 7. So, this is the way we can calculate if x is divisible by 3. And the next question, a random variable x has the following distribution, x equal to 0, 1, 2, 3 and so on 7, and probability of x equal to 0, k, 2k, 3k, 2k repeated, 3k, k square, 2k square, 7k square plus k. I hope you can do the activities, find the value of k, and probability of x lies between 1.5 and x less than 4.5 such that x is greater than 2. So, based on the conditional probability. Third question is the smallest value of lambda for which p of x less than or equal to lambda is greater than 1 by 2. Now, the total probability value is 1. Therefore, simply add 0, k, 2k plus 2k plus 3k plus k square plus 2k square plus 7k square plus k. Therefore, we have 10k square plus 9k equal to 1. So, 10k square plus 9k minus 1 equal to 0. Factorize, it becomes 10k minus 1 into k plus 1 equal to 0. Therefore, 10k equal to 1 mean k equal to 1 by 10 and k equal to minus 1. So, these are all the two values. The value k equal to minus 1 makes some values of p of x negative. Therefore, k equal to 1 by 10 will come. Now, we have a distribution x equal to 0, 1, 2, 3 and so on 7, and p of x equal to corresponding value 0, 1 by 10, 2 by 10, 2 by 10, 3 by 10, 1 by 100, 2 by 100, 17 by 100. Now, we have a probability of 1.5 less than x less than 4.5 divided by x greater than 2, which is equal to probability of A by B. This is a conditional probability. So, the formula for this one is P of A intersection B by P of B, and P of A intersection B is given P of 1.5 less than x less than 4.5 intersection x greater than 2 by P of x greater than 2, and the value P of 1.5 to 4.5 is nothing but x equal to 3 and x equal to 4, and probability of x is greater than 2 is nothing but start from 3 to 7 of total probability of x equal to r. Now, you have to substitute from the table corresponding 3 we have a 2 by 10, corresponding this 2 by 10, and for 4 we have a 4 by 3 by 10, and then probability of what summation r equal to 3 to 7, that is 2 by 10 plus 3 by 10 plus 1 by 100 plus 2 by 100 plus 17 by 100. So, we have 7 by 100, that is 7 by 10. So, numerator is 5 by 10, denominator is 7 by 10. So, the value is what 5 by 7. So, this way we can calculate the values lies between 1.5 to 4.5 and depends on when x greater than 2. The third question, the smallest value of lambda for which probability of x is less than or equal to lambda. So, by trial x is less than or equal to 0 is 0, and x less than or equal to 1 is nothing but 0 plus 1 by 10 is 1 by 10. X is less than or equal to 2 means probability of x equal to 0, probability of x equal to 1, probability of x equal to 2. So, we have 0 plus 1 by 10 plus 2 by 10, which is equal to 3 by 10. So, that is the value of what this trial. Probability of x is less than or equal to 3 mean 3 by 10, and then if x is less than or equal to 3 is 5 by 10, do the same way, and probability of x is less than or equal to 4 mean x equal to 0, 1, 2, 3 and so on 4, add them, we have 8 by 10. Therefore, lambda is a smallest value satisfying probability of x is less than or equal to L, that is greater than or of is 4. So, this way we can use with the help of what cumulative probability distribution function. Next question, if p of x equal to x into e power minus x square by 2 when x is positive, show that p of x is a PDF, that is probability density function or continuous random variable of x. Find the distribution function of p of x. If p of x is to be a PDF, then p of x is a positive, then integral, that is the definition of integral r of x is p of x dx equal to 1. If you have p of x equal to x into e power minus x square by 2, if x is positive and otherwise it is 0, otherwise it is 0. Now, the integral varies from 0 to infinity. So, the p of x value is x into e power minus x square by 2 into dx, and here you have to do the substitution, put t equal to x square by 2, therefore, dt equal to 2x dx by 2, right, and 2 get cancelled x dx, therefore, dt equal to x dx, right. Therefore, x equal to root of 2 into t, therefore, the equation reduces to e power minus t dt. Once you integrate e power minus t dt, so we have e power minus t by minus 1 and over the limit 0 to infinity, then e power minus infinity minus the minus plus e power 1 So, e power minus t is 0, then value is 1, therefore 1. So, the value is 1, implies p of x is legitimate PDF of random variable x, and f of x equal to probability of x is less than or equal to x, which is equal to integral 0 to x f of x dx. Now, f of x is 0 when x is less than 0. If f of x is the values varies from 0 to x into e power minus x square by 2 dx is 1 minus e power minus x square by 2 when x is positive. Next example, if the density function of a continuous random variable x is given by f of x equal to ax when x lies between 0 to 1 and a if x lies between 1 to 2 and 3a minus ax when x lies between 2 to 3, otherwise 0. Now, the question is find the value of a and find the CDF of x, and if x1, x2, x3 are a 3 independent observation of x, what is the probability that exactly one of these 3 is greater than 1.5? The solution is f of x is a PDF, therefore, integral Rx of f of x dx equal to 1. Now, we have an integral from the range 0 to 3 is given, therefore, the lower limit is 0, upper limit is 3 into f of x dx. So, let us start with 0 to 1, 1 to 2, 2 to 3. So, when 0 to 1 the limit is ax is given here, and 1 to 2 the corresponding value is a, and 2 to 3 corresponding value is 3a minus ax. Now, we have to integrate. So, first one integrate what happened, a into x square by 2 over the limit 0 to 1. For second one, a into x over the limit 1 to 2. For the third one, 3a into x minus ax square by 2 over the limit 2 to 3. So, net value equal to 1. For first case, x equal to 1, therefore, a by 2 will come. For second one, a into 2 minus 1 is 1. For third one, the upper limit is 3, therefore, 3a into 3 minus 9a by 2 minus of 2, right. X is 2, therefore, 6a, x is 2, 4 by 2 is 2a equal to 1. Now, we have what, a by 2, right, a 9a minus 9a by 2, therefore, 18a minus 9a is 9a by 2, and then 6a minus 2a is 4a, therefore, minus 4a will come. Now, you take LCM, you have what? So, this net value is totally 2a will come, 2a equal to 1 implies a equal to half. So, this is derived here. So, we have taken the values from the integration of the probability density function, so that a value determined. So, once you know that a value, we can directly write f of x. So, f of x equal to probability of x less than or equal to x is 0 when x is less than 0, and capital F of x is nothing but 0 to x by 2. So, integrate it x square by 4 when 0 less than or equal to x less than or equal to 1, and then x value varies from 0 to 1, therefore, the limit change 0 to 1, x by 2 dx plus 1 to x 1 by 2 dx. So, the net value is what? X by 2 minus 1 by 4, when the values of x is lies between 1 to 2. Further integrate it, we have 3 by 2x minus x square by 4 and minus 5 by 4, and x values from 2 to 3. So, corresponding value will be 1 will come when x is greater than 3. And similarly, we can go for probability of x is greater than 1.5. So, we have the integral 1.5 to 3 f of x dx. So, according to the table, this can be splitted into 1.5 to 2 and 2 to 3. 1.2 to 1.5 to 2 corresponding value is half dx, and 2 to 3 the corresponding value is 3 by 2 minus x by 2, and integrate it and apply the limit upper limit minus lower limit, we have 1 by 2. Now, choosing an x, observing its value can be considered as a trial, and consider a success p equal to half, q equal to half. So, we choose 3 independent observation of x, n equal to 3. By Bernoulli theorem, probability of exactly one value is greater than 1.5 is probability of one success equal to 3c1 into p into q square equal to 3 by 8. So, up to this, stop it, we will continue.